So before anything else, let me introduce to the topical workbook for computer science 2210 or 0478. This is the workbook 1 for paper 1, basically computer systems. And as you can see from the table of contents, I've included questions on each and every subtopic from the syllabus along with the mark scheme. And these are some of the actual questions, actual pages as a preview from the workbook. Section 1.1, 1.3, 2.2, 3.2, 5.3 cybersecurity and artificial intelligence. This is just to show you a glimpse of what type of questions are included in the workbook. There are many more questions where these come from, and around 18 to 20 questions on an average are included for each and every topic. A must buy if you want to boost your grade. Similar to the paper 1 workbook, I have designed a paper workbook for paper 2 as well. This is for algorithm, programming and logic for CAIEs either 2210 or 0478 GCE or IGCSE Computer Science. As you can see, it contains questions on every subsection of the syllabus content for paper 2 along with the mark scheme, so you can understand each and every question, each and every algorithm. These are some of the few pages from the workbook just to give you a glimpse of what type of questions are included. As you can see, this is 7.1, this is 7.7, 8.3 and section 10 Boolean logic. So a lot more questions are included in the workbook. A must buy if you want to have a very good score in your Cambridge examination. Order now. Assalamu alaikum warahmatullahi wabarakatuh. How are you guys doing? I hope everybody is fine. So we were discussing physics and we were on section number 1, motion, forces and energy, and continuing on with our topics. Today we are going to discuss section 1.4, that is named as density. This is a lecture for physics 5054, or if you're an IGCSE student, then your code is 0625. So let's dive in and see what this topic has to offer. Now, before discussing density, you need to know what volume is. So volume is the amount of space occupied by an object. It's measured in cubic units, and the standard unit of or the SI unit for volume is meter cube. Whenever you are having a volume, its unit always have this cube sign with it. It is a scalar quantity. Volume of a regular object can be calculated by taking measurements of its sides and then plugging them into relevant formula according to the shape. Like if you have a cuboid, you can simply use a ruler to find the length of sides and then multiply them together to find the volume. If you have a very small cube, then you may use a vernier caliper or a micrometer to find the length of side and then multiply it with itself, length into length into length, and so on. If you have a cone, and you may use a tape measure or a meter rule, and so on. So depending on the shape, a regular shape of a 3D object, you can use the formula of volume for that specific 3D shape and find the volume. Volume of an irregular object can be calculated by using the displacement method, and for doing that we fill a measuring cylinder with water or any other liquid and take its reading. This is known as the initial reading. Then the object whose volume is to be found is placed inside that measuring cylinder or is immersed in that liquid. Obviously when you put something in a liquid, its level rises, and the new reading, the final reading after the water or the liquid has risen up, is taken, and by subtracting initial reading from the final reading, we get the volume of that specific irregular shaped object. Something like this. This was a steel block. This was 76 centimeter cube of water. You can check it yourself. Let me I hope you can see it clearly now. 20, 40, 60, and before 80 there are 5 marks for 20 units, so that means 1 mark is of 4 units, and the lower minuscule is over here, so 76. Whereas this one is 100, 120, 130, and this is 4 units before 160, so it should be a 156. And so initial volume is 76, final volume is 156, and for finding the volume of the object we simply minus or subtract these two together. 156 minus 76, the volume for this steel block is 80 centimeter cube. Now over here I have given the example of a steel cube, but normally we use this method for finding volume of irregular shaped object. Now that we have talked about our volume, the next step is to calculate the density. And for finding density, what is density? Density is the mass of an object per unit its volume. How much mass is contained by an object for every unit of its volume? That is what density is. And density is often represented by the Greek symbol rho, and a rho is written something like this. It looks similar to P. The SI unit for density is kilograms per meter cube, kg upon meter cube, and it is a scalar quantity. As it is not consistent with the vectors, neither mass nor volume is vector, hence density is also not vector. Density is commonly expressed in another set of unit as well, that is known as gram per centimeter cube. In your question paper you would often have to convert between these two units, so for that remember this simple conversion technique, that 1000 kilograms per meter square equals to 1 gram per centimeter cube. Density can be calculated by using the formula mass upon volume. The density of a substance does not change as you move from place to place, as the mass and the volume does not depend on the gravitational acceleration of the point that the object is at. So if a piece of iron has a density of, let's suppose, 2 grams per centimeter cube, it would remain at that value even if you take it into outer space. The experimental setup to find the density of an object looks something like this. You use a balance to calculate the mass, and you use the displacement method or a measuring cylinder to measure the volume, and then you plug the values into the formula mass upon volume and calculate the density. Now if mass is given in grams then and volume is in centimeter cube, you get density in grams per centimeter cube, and if you have mass in kilograms and the other value in meter cube, then you would get it in kilometers per meter cube. Kilograms per meter cube. Now if you are given one value in grams and the other one in meter, then you will have to convert either of them into the appropriate unit. Either you'll have to convert meter into centimeter, or you'll have to convert grams into kilograms. Otherwise the value of density that you calculate would be wrong. Density of a liquid. Measure how to calculate the density of a liquid. Measure the mass of the liquid by weighing it in a container. Pour the liquid out and then weigh the empty container. Minus the two values and you get the mass of the liquid that was in the container. Means mass of container plus liquid minus mass of empty container would give you the mass of the liquid. And to find the volume of the liquid, simply fill it in a measuring cylinder and see how much volume is there, and then plug the values into the formula and you calculate the density. And if you have to find the density of a gas, simply measure mass of a container such as a graduated flask, a round bottom flask, a flat bottom flask, or any other container, Then using a vacuum pump, suck out all the gas and weigh the empty flask or the empty container. The difference gives the mass of gas in that container, and volume of the container or the volume of the gas can be found simply by remembering a simple rule that the volume of a gas is same as the volume of its container. So to find the volume of a container, fill it to the brim with the liquid or with water, and then pour that water out into a measuring cylinder and just check how much water was there in that container. Once you have the value of mass and volume, you can plug them into the formula and calculate the density of a gas. Floating versus sinking. Now this is a little concept that was explicitly a part of the syllabus before, but now it is simply hinted at, and as it is a very basic property of density or something that is closely associated with density of an object, it's better that you study it as well. An object, either it is a solid or a liquid, will float on top of another liquid if its density is less than the liquid, whereas an object will sink either partially or either fully if its density is heavier or greater than the liquid. For floating and sinking, we don't really talk about gas, but if you have two gases inside a container, then the gas with less density would be in the top part of the container, and the gas with a heavy density with a greater density would be in the bottom of the container. This is an example question. This is a bar of aluminium, and you have to describe how the density of aluminium may be determined using this bar. Remember that when we find the density of a piece when a small piece of a metal, then it is generally the same as any density of any other piece of that specific metal. Means every material, no matter wherever it is, would have the same density. Like the wood of the density of a specific type of wood would remain constant all around the world. The density of iron would be the same all around the world, no matter what size of an object and what mass of an object you use to determine the density. So this is one way of differentiating between metals, that you check you calculate the density of the unknown metal, and then you compare it with the density chart, and you can figure out what metal was used to construct that given object. Anyways, coming back to the question, you have to describe how to calculate the density, and you have to describe the readings to be taken, and you have to state the instruments that how you are going to take the readings, and you are going to describe how density is calculated from these readings. So a sample answer can be like this, that a mass of bar can be measured using a top pan balance or an electronic beam balance or a normal non-electronic beam balance. Electronic balance is also known as top pan beam balance. The length, breadth and height of the bar can be measured using and you can use them to calculate its volume by applying the formula length into width into height, as this is a cuboid. And for doing that, you can either use a vernier caliper, a micrometer or a meter rule, depending on the dimension, how big that aluminum bar is. Over here it seems big enough that you can use a meter rule in order to calculate its length, whereas for the width and for the height or the breadth you can use either micrometer or a vernier caliper, because these two readings are quite small, or at least they appear to be. Now, and for finding the volume of this metal bar, what you can do is you can use the displacement method. You can fill a measuring cylinder with a known amount of liquid, and then you can immerse this piece of metal inside that measuring cylinder, inside that liquid, and then you take the new reading, subtract those two readings, and you get the value for the volume. Once you have the, or you can simply use the formula length into breadth into height. You can go either ways. It's up to you how you describe your experiment, but it's better if you describe it by using a formula, because they have asked you to mention what instruments you are going to use and what measurements you are going to take. Anyways, once you have the value for mass and for the volume, you can simply find the density by using the formula mass upon volume, whatever it may be. So this is it for section 1.4. I hope you have understood everything. Please do give your comments below so I know how well you're liking or not liking the physics lectures. Also, if you find any discrepancy, please do mention it below in the comments. Like and subscribe to my channel, and please share it with your friends as well. And I'll see you guys in the next video with another topic. Take care. Allah Hafiz.